Hey everyone, we are back. This lesson is gonna be dedicated to training sessions to train your AI model how to detect the cells, the cell bodies at least, and on the different channels. For example, the CFOS channel, the one that is GFP, and the DAPI. I'm gonna show it right now. So here is our, excuse me. So here is our folder with, I'm gonna delete this one because we're not gonna use it since I just did try to make it before I started recording. So I'm gonna delete it. Please do not delete it, okay? So let me just put it somewhere else. Oh, wait. I'm sorry. So just basically, please do not pay attention on this folder since I have been already working on that, but we are gonna make a new one. So as I previously said in the first lesson, when we just installed all the BrainJ stuff and we set the experiment parameters, now when we open the Fiji, I'm gonna open it right now. As you remember, we go to plugins, then we go down till we see the BrainJ. We open it, and first to do is usually we set the experiment parameters, and I want you to pay attention on this thing. So when you open the experiment parameters, please be sure that you identify the right counterstain channel, which is your basically all the nuclei, usually the DAPI. So for me here it is the first one that you don't have to pay attention on, or it can be also third one. In my case, I'm not sure. I will try both and see which one is it, because usually I'm not sure still how this thing works, but in case if you get the error that you're on this step, on the fifth step here at the end, I'll show you the registration and atlas analysis. If this one does not work, it means probably that something is wrong on your experiment parameters. Maybe the folder is wrong or the counterstain channel is wrong. Yeah, something like that, but not the rest. Okay, so here it is. Okay, I chose the first one. Now maybe, you know what, let me try it now to set it at the third one or the second one. Okay, and let me go and check the images. So if you open the reformatted sections, here I have like, I'm sorry, let me just check something. Okay, so this is also like, do not pay attention here. I just made it on my own. It should be something like that when you already reformatted all the sections. So basically you just get two different channels. I have here the CFOS channel, GFP, which is green, as you can see, in one folder, and in the second folder I get in the second folder I get the blue staining, the DAPI staining. Okay, here it is, and this is quite, I'm just like, I don't really need the DAPI here because it's just the main thing here is CFOS. Okay, so now let's go to training. As I mentioned in the beginning, you have to also download these two examples of Ilastik project channels that you can see here in the GitHub PDF file with the guidance. or it's written even in the first page of the GitHub. It's here. Don't forget to download the Atlas files and the Ilastik project. So when you download Ilastik project, just transfer it somewhere near your computer, like wherever you want. And I would put it somewhere near my folder of the main experiment project. And then what I would just do, I would open the Ilastik and wait a little. And now it's open. And then you push, you press the button Browse Files, and then you open it again. This is a very poor UI UX design, so it's not really comfortable, but this is what we have. So we open first channel, open it, and now let's see how. Okay, so here you have the example that will show you that is shown by the developers of the BrainJ, how to mark and train your model. So for example, if I zoom out, you can see some yellow and blue spots, and each color means its own labeling. So the yellow is the cell bodies, the blue is projections, accents or dendrites, and background is basically the red one. But since this is not the image that we need to train on our model, we have different staining, hence we have different stuff. So we just use right click on the, first you go to the input data, then you go here, first select first image, right click and replace with the file. Click it. Now you go to the reformatted sections. When it depends on where does it open, and I would just go to reformatted sections of my project and pick up one image, doesn't matter which one. So, but it should be only of the first channel. Okay, so do not pick one image from one channel and second image from DAPI channel, let's say, because it's different staining and you will have different images. So you train your model separately, each channel separately. I also want to explain you what is training, what does a training mean itself. So basically what we do is pretend that your machine, your computer, is a kid and you want him to learn what is what. For example, you can say to kid hey, this is a red color. You point every time you see the red color, the red apple, anything red, for example, and you always say red, and this is how your kid is learning that, yes, okay, so this color is red now, so I need to use this word to when I mean the color of red. Okay, so this is the same when you want to teach your computer to know that, hey, this is a cell and this is the cell and this is the cell and this is, so you just point to different spots, different shapes that you can see of the cell staining, and then it looks at it and the machine reads it pixel by pixel, and it's oh, okay, now I know that this one, and this one is cell, and then it trains itself. So it just tries to get the random one and identify if it is a cell or not. If it looks like what you pointed out to him, to the computer, it will identify it as a cell. If it does not really look like, it will skip it. So it's just that easy. Okay, so now we chose the first one. Let's go to the second one. I will right click and replace with the file. And then I would pick So that one was 002, and I'll pick 005, let's say. I don't know, it doesn't really matter. Although you, like, preferably it's better to choose representative images. So those that really show the, like, very, very normal. Not too good, not too bad, but very normal, you know, like those that would be considered as the normal ones. I will not pick another, although you can add a new. If you have a lot of images, for example, you have like if you want to make a brain reconstruction and you have like 60 images, you of course can pick 3 to 4, maybe even 5, as you wish. If it's from different animals, it's better to pick one image per one animal, so that you will keep, like, so that you don't make the training only on the one animal, and the other animals can have some different some, you know, like, differences, so that your kid, aka your machine, will not get confused. But I will just show you how to make it, and you can just do whatever you want. Here, the second one is the feature selection. And the feature selection is very important, but you actually do not have to pay attention on it. Since you downloaded the example project from the GitHub, they already picked up all, like marked all of the stuff that you need. So they use the Sigma. It's like a probabilities, and I actually don't know exactly what does it mean, but so yeah, it's like the magnitude. And they already did it for you, so you don't have to do anything here. I'm just showing it to you. I'm just gonna close it. Then you go to training. This is the main thing that we're gonna do. So what we have here is the cells, the projections, and the background. And I'm gonna just zoom out to take a look on the main image, no, on the whole image. And then I would pick any region. Let's say, okay, I like this region, and I would go here. So I would just zoom with my mouse here, and I would pick the yellow color, which is the cells. And now I'll just do like that. Okay, this is the cell, and this is the cell. I like this one is the cell. So just labeling those that you would mark as the cell. I'm not gonna label more. I think this is like 6 to 10 per one zoom is okay. I'm gonna make like 3 or 4 zooms in different brain regions. By the way, you can move your move to another brain region by the arrows on the keyboard. And for example, here I like this region, and I would zoom again. Okay, this is not really. Yeah, I would probably do it here too. I think that it would work. Maybe here. This one is also look like. This one I will not mark because it looks really strange. It's probably something on the. Something happened on the slice. Okay, and let's go now to another region. It shouldn't be very like organized. You just behave as you would behave, like very randomly, chaotic. So you just like the region, you get it. By the way, here, for example, you see, I misclicked. So if you if you stain something like that, no worries. You can take the. By the way, the Control Z does not work here. I don't know why. So you just get the on your toolbox. You get the eraser. You can change the the size of this eraser, and make a big one. For example, this one, 31, and just erase them. And that's it. Now you have no labeling here, not label it here. So just chilling, nothing really hard. You don't need any like hard skills to do this. I don't like it. I would do this maybe by 5. You can change the size of a brush for your cell staining, for example, and you would move on right here, for example. Oh, that's okay. I think that's enough. And then maybe we will go to this area. Mark just a couple of them. And I would go outside. Okay, now let's check the accents and dendrites. Actually, I'm not really sure that we will see them here because the staining that I have here, the images, do not stain. They stain in the cell body. So it's not really. If you want, if your staining is with the accents and dendrites, and you have, like, for example, what do we have, like a map 2, I guess, can be, or for example, if you stain the tubulin, you can get the accents and dendrites, and then you would stain them with the green, or with the red, I'm sorry, with the blue one. Well, I'll just use my imagination and I'll say, like, what if there is, it will not work. I just want to show you what if. So I would pick the really small size, let's say 3, or even actually even 1, and I would make an, let's say, what if there is a line here, and I would just follow it, and there's another line here, and I would just follow it, and for example there's another one line here, and I would just follow it. This is how you do it. And if you don't, for example, if there is a line here like that, and then there is something that you are not sure, you don't see the line, and then you see the continuation of this line, I would just do like that. I would just do like then, and then I would just connect them. It doesn't matter. If you are more or less sure that this is the same accent, do it, and you will teach your machine how to, let's say, predict the where is the continuation of the accent that starts here and finishes here, for example. So if you want your machine to behave like a human, to be able to predict, identify, then use your skills and show it to him. Okay, so I just erased them because we don't have accents here and I don't want my model to fuck up. Okay, sorry. And now let's take the background, the red one, and just go here. And for example, I don't want the black to be labeled, so I'll just put a couple of dots here on the black one. And then what I will do is I'll just, for example, I don't want my machine to quantify something that I think is non-specific staining. For example, this one. I don't like it. I would not count it. This one as well. So the intensity of the fluorescence is not really enough to to look like it is what I need. So I'll just make a couple of dots here, for example, here, so that my machine would not identify everything as the staining. I think that's okay in this region. Then let's go somewhere here. Maybe the first one will not be the perfect one for you, but with time I think everyone can master the skill of, like, just do how you feel, and with the results you will see if they are satisfying or not. If they are not, you can always retrain your model. Maybe, for example, you will choose not to choose this as a background next time, and something like that, you know. This is what we do. We just learn by this, by trying and then being wrong. Yeah, and then we can always redo a lot of stuff. So I think that's enough. That's more than enough, I guess. So the first image is ready. The first image is labeled. Training is not started yet. Then I go to the second one here, and then here I will start from the background, because I already know what I will mark as the background, and I'll just be very chaotic. Let's go here. This one I will not mark. Yes, so that the machine can identify which exact, how to say it, like range of fluorescence is enough for us to identify the cell as the cell. And it's important, for example, for projections, it's important not the fluorescence, but the shape of your mark means, because it's elongated, it's more like a line, it's not a dot. That is how your machine will identify it as, yes, this is the projection. And plus you will say it here because it's blue, right? Okay, so I think that's enough for the background. I'll just do like that. I think it's not, yeah, just doesn't matter. Now let's go to the cells, and I'll zoom in. Wait, I'm sorry. Here I will use 5. Yes, 5 is enough. This one. Okay, and some training here. Okay. It will read pixel by pixel, so you will see, like, after we figure out. Okay, I'm gonna do the pause and then we will see. I mean, because since you've seen the how did I do the first one, it will be easier just to not make this video too long. I'll put a pause. Okay, I finished with the training, and now we can just save it, pressing Ctrl S, which will save the document. Remember, you opened the one that was here, but now we need to press on the project, save project as, and then go to the folder of your experiment, and then you see here Ilastik projects. Take this one and save it as the channel 1. Okay, so the name should be just the same, and then choose the number of channel that of your images that you were training. Then I would say save it. Yes, because I already got like one. Oh yeah, and so there can be a problem, this kind of error, which is missing file. It can happen if you moved the image from your if it was like, for example, here in this folder, and then you moved it here, or it was from different experiment, maybe. Yeah, because like you can always make if you want to train your model well, you can choose your images from different animal, which is from different experiment, and it is totally okay. The main thing is just it has to be the same channel and the same condition. So in case if there is a problem, you just have to either change. Now it's not responding. 1 second. Let me just close the program. So you can just gather all the images that you're using, for example this one, and then I would take the one that is here, this one, number 4, and then I would put them into one folder here, and I would use only them. This one is most convenient way. Yeah, I suggest you to do that. So now when we have channel 1, let's move to channel 2. I will open it now here, and you just do the same but with another channel. So I will just show you the first steps, and then we will already move to the training itself. So here I'm gonna do this. I'm sorry, I forgot something. Yes, we should open not this one, the one that was from the example, the one that we downloaded. So it's this one. Then we open it, and now this is the example image. As you remember, first step, change it. Right click, replace with the file. Now you go to the second channel, and this is a DAPI. I'll choose the third one, and this one will be replaced with the 5th one. Okay, we go to the training, because we don't need to select any features. Go to training immediately. Now we see there's much more. You see there's much more staining. So this is basically all the cells, the nuclei, so that's why we don't need. I'm gonna just click on them, and in this case I will not be very strict with the background. Sorry, let's make it 5. So I will accept all the nuclei here, because this is the DAPI, this is not that important. Okay, so I think that's enough for this brain region. Then the projection, so skip, and the background will be just the black stuff. Here, here, here. Those that you don't want to count, and of course the machine will. It doesn't matter. The shape does not matter, because this is just black background. make it here, for example, and just here. Yeah. Oh, okay. For example, here, you see, it looks like there's nothing, so this should also be excluded. Let's see if we can exclude anything else. I think we're good. Okay. Now we just move to the second one, to the second image. Just do the same. This is the background, this is the background. Seems like there's less. You can just if you want better results, of course you want more labeling. So you can work really hard on labeling stuff. Of course, do not label everything, otherwise you'll just do the work instead of machine. But it would be really good if you label around, if you put around like 100 labelings among all, not for each image, like overall. Okay, so that's it. This is it. Now we should save the project as save it right here to Ilastik project. So I'll save it here. Yes, and now I can close it. Okay. So now our model is trained. We have training for the model, but it's not trained yet. To start it, you should watch the next episode, basically. This is just to show you how to train your model. Thank you for your attention, and see you on the next lesson. Bye.